In the grand story of humans on Earth, we are quickly approaching another apex. Some say we have already reached the top of this metaphorical mountain, but from this vantage point, we can see where we need to be. We can also turn around and see where we've come from. Knowing it will take a different set of strategies than getting up to the top, it's time to change the plan. We need to shift the narrative from an end-of-the-world mentality to it's the end of the world as we know it, and innovate. Better. I firmly believe that an incremental shift in perspective can radically change the way we plan and design the future. So, what is the first step to changing perspective? Observation. Observation is a key design principle. It is also the first step in the scientific process. Observing is powerful. It's not passive. It's a type of non-action. It's what Buddha claimed to have brought him into enlightenment. Observation is learning. It's active listening. It's paying attention. And the best thing to pay attention to is nature, Earth, and all of its components. When we begin to notice how nature works, we can turn that well-informed bio-inspiration into creation. Otherwise, we are observing phenomena that has gotten us to become unnatural. Daniel Christian Wall, an international consultant and educator specializing in biologically inspired whole systems design, says that paying attention to life's 3.8 billion years of distributed collective intelligence coded into a marvelous diversity of species and the relationships between them within an undivided, continuously transforming whole can teach us a whole lot about how to design and act more wisely. Bioinspiration has become the umbrella term for design approaches that use biology as a resource for solutions. There is bioutilization, which directly utilizes organisms or biological materials, bioclimatic, bioethics, biomorphism, which is mimicking natural forms and patterns, biophilia, bioengineering, bionics, which is mimicking machinery to function like living organisms, and biomimicry. Bioinspiration is a way to integrate anthropocentric and biocentric design, coming from a degenerative past towards a regenerative future. My question is, how do we apply this directly as environmental stewards? Biomimics, at their best, err to design as nature. To me, that means creating conditions conducive to life, aiming to create salutogenic, health-generating design while pursuing whole systems optimization rather than the maximization of individual and isolate parameters. Not being a biologist, it's difficult to imagine inventing something akin to sharklet technologies, which is a surface that repels bacteria without the use of biocidal chemicals, inspired by the anti-fouling properties of shark scales, or the Senecar beetle-inspired water-collecting methods. They use the surfaces of these wing covers on the beetles to gather water using nanoscale bumps and body position. Within the first steps of bio-inspired thinking is asking the question, what function do I want to solve for? So as an example of how to start, I began looking for fungi-inspired innovation. I was able to identify some of their functions, strategies, and context. The main line of fungi lore goes as follows. Once upon a time, there were no lignin-digesting organisms, and trees were polluting the earth. Then, Agaricomycetes, ancestor of the button mushrooms, arrived and saved the world, for species like us anyway. Nowadays, we have predicted there are estimated to be as many as 5.1 million species of fungi. And on AskNature.org, a spectrum of scientists have recorded their fungi-related observations for us. The saucer-like top of a bird's nest fungus launches spore capsules by deflecting heavy raindrops that dislodge the capsules and disperse them. Spores of the Basidiomycetes fungus disperse using a surface tension catapult. The sporangium at the tip of the hypha of the Pilobolus fungus launches spores using hydraulic system. Free-living Asomycetes growing in colonies can spread into the extremely hostile environments including deserts because they possess extracellular polymeric substances and other adaptions. Hydrophobins produced by the splitgill fungus protect surfaces by self-assembling into a highly water-repellent layer when exposed to an air-water interface. The metabolism of Aspergillus and other microscopic fungus is capable of breaking down hydrocarbons in crude oil. Extracellular enzymes in mycelial growth in Pleurotus austratus fungi and the fungus Gliocladium roseum mediate the breakdown of a common industrial compound by initiating the biodegradation process. Enzymes produced by the mushroom-forming fungus Agrocybe agarita break down toxic organosulfur compounds by catalyzing the oxidation of the sulfur-containing portion of the molecule. Several species of epiphytes, ants, fungi, and butterflies in mangrove forests provide benefits to each other through mutualism. Arizona fescue grasses may have increased resistance to fire thanks to the endophytic fungi Neotyphodium stari. Fungal gardens of leafcutter ants are free of undesired parasitic fungus due to a presence of symbiotic Streptomyces bacteria. Most of the designs for the Biomimicry Challenge and other bio-inspired innovations use multiple functions and strategies of organisms. The fungi ones have ranged from biofuel from the Gliocladium roseum, air filters, water filters, housing from reishi and other polypore mushrooms, compost accelerators, community networking, fungi-based pesticides, economic biomimicry from fungi to plant, mutualism and symbiosis, and even making better solar panels. This is probably 1/10,000th of what fungi can do design-wise. Although the overarching lesson I have learned from fungi is that they are the end of the circle of life. They close the loop on many of plants and animals' biological timelines, a key feature for ecosystem function, one that is overlooked in our production lines. When we design, we have to shift from a linear view and remember that everything will need to break down to make room for more. The group Biomimicry 3.8 estimates that by 2030, bio-inspired products and services will generate $1.6 trillion to the global GDP. Companies and groups all over the world are turning, or perhaps returning, to this type of design. With a shift in perspective from what we can use in nature to what we can learn, we can arrive at the best outlook to see where we need to be from the vantage point we are at. And bio-inspired innovation has another lesson to teach us. Janine Benyes writes, "Perhaps in the end, it will not be a change in technology that will bring us to the biomimetic future, but a change of heart, a humbling that allows us to be attentive to nature's lessons." Bill McKibben has pointed out, "Our tools are always deployed in the service of some philosophy or ideology. If we are to use our tools in the service of fitting in on Earth, our basic relationship to nature, even the story we tell ourselves about who we are in the universe, has to change." The future will take biodiversity, innovation, and 3.8 billion years of lessons times 7.6 billion minds of creators. This changing of heart coincides with bio-inspiration. Anyone that spends enough time outside knows this. We have so much access to the right kind of tools and techniques, but it's this shift in our perspective that will set us down the right path on the mountain.